Good morning. It's December 18th, and this is your daily brief in science. Here's everything you need to know. NASA has announced a significant delay in the return of astronauts Suni Williams and Butch Wilmore from the International Space Station, extending their mission from the planned 8 days to nearly 10 months, with a new return date set for late March 2025. This delay is primarily due to ongoing issues with Boeing's Starliner, which has yet to complete a crewed mission, while SpaceX has successfully transported astronauts since 2020. The situation has become a notable embarrassment for Boeing, which has struggled with the Starliner program amid SpaceX's regular mission successes. The Starliner crew's launch, initially scheduled for June 2024, faced multiple technical challenges, including propulsion system failures that prevented a safe return with crew, ultimately leading to an uncrewed mission instead. Originally, NASA planned to return the astronauts in February 2025 using a SpaceX Dragon capsule, known for its proven track record. However, additional time is now needed to prepare a new capsule for the upcoming crew launch. Despite the extended duration of their mission, the ISS remains well-stocked with essentials, following successful resupply flights that included food and holiday items for the crew. Williams has reassured the public about their well-being, stating that they are in good health and enjoying their time in space, despite social media concerns over the prolonged mission. Both astronauts have expressed their adaptability to the extended mission, drawing on their military backgrounds and previous deployments to manage the unexpected changes. During their extended stay, Williams and Wilmore are expected to conduct various scientific experiments aboard the ISS, utilizing their extensive experience as astronauts. NASA aims to ensure that any debris from the ISS burns up upon re-entry, with remnants expected to land in a remote area of the Pacific Ocean known as Point Nemo. The ongoing delays raise concerns about future space travel logistics and the overall mission timeline, highlighting the complexities involved in astronaut safety and transportation. SpaceX's Dragon spacecraft has completed another successful mission, marking a significant milestone in the ongoing partnership between NASA and SpaceX. Launched from NASA's Kennedy Space Center on November 4, 2024, the Dragon was part of SpaceX's 31st commercial resupply mission to the International Space Station. It arrived at the ISS the following day, where it delivered crucial supplies and scientific research materials. After a month-long stay, the Dragon spacecraft undocked from the ISS, executing a command from SpaceX ground controllers. It carried back over 2,700 kilograms of cargo, including crew supplies and valuable samples from experiments focused on human health and biology. The spacecraft successfully splashed down off the coast of Florida, where NASA plans to quickly retrieve the CRS-31 Dragon to continue research on experiments that require prompt attention following re-entry. During its mission, the Dragon delivered fresh food, research equipment, maintenance supplies, and personal items to support the astronauts aboard the ISS. On the same day as the Dragon's undocking, SpaceX conducted a 6th test flight of its Starship rocket, an event captured by astronaut Don Pettit from the ISS, who has been sharing stunning images and videos from space. The Expedition 71 crew, including astronauts Butch Wilmore and Suni Williams, continued their work on the ISS, focusing on servicing advanced exercise equipment and reconfiguring a science airlock. It's worth noting that the Dragon's undocking was initially scheduled for December 6, 2024, but was delayed due to adverse weather conditions in the splashdown area. For ongoing updates about the ISS and related activities, NASA encourages following their space station blog and social media channels. Atsena Therapeutics has reached a significant milestone in the development of gene therapy for X-linked retinoschisis, or XLRS. The company announced the completion of dosing in Part A of the Lighthouse study, a Phase 1-2 trial evaluating their gene therapy product, ATSN-201. This open-label trial focuses on the safety and tolerability of ATSN-201 in male patients aged 6 and older, with enrollment still ongoing. The Lighthouse study assesses 3 different dose levels of ATSN-201, administered via subretinal injection, in 9 adult participants diagnosed with XLRS. Initial results from Part A of the study have shown both structural and functional improvements in the treated patients, with no serious adverse events reported. XLRS is a genetic condition that affects approximately 30,000 males in the US and EU, typically diagnosed in early childhood, which can lead to impaired vision and eventual blindness. ATSN-201 has received orphan drug and rare pediatric disease designations from the U.S. Food and Drug Administration, highlighting its potential importance in treating rare genetic conditions. The therapy employs a novel AAV.SPR capsid, which enhances the efficiency of gene therapy by allowing for better spreading beyond the injection site while minimizing surgical risks. Dr. Kenji Fujita, Atsena's chief medical officer, stated that these results validate the efficacy of their novel capsid for treating inherited retinal diseases and will inform the next phase of the trial. Patrick Ritchell, CEO of Atsena, expressed optimism regarding this milestone for XLRS patients, noting the lack of approved treatments and the potential implications for other inherited retinal diseases. The company is looking to gain further insights from the trial to advance ocular gene therapy approaches, with ATSN-201 designed to deliver therapeutic levels of gene expression in the central retina's photoreceptors. A new study from the University of Surrey has revealed concerning health effects linked to plant-based meat alternatives, or PBMAS, among vegetarians. Published in the journal Food Frontiers, the research indicates that vegetarians who consume these products face a 42% increased risk of depression compared to those who do not. The study found no significant differences in sodium, free sugar, total sugar, or saturated fat intake between PBMA consumers and non-consumers. However, those consuming PBMAS showed higher blood pressure and elevated levels of C-reactive protein, which suggests increased inflammation in the body. Additionally, PBMA consumers had lower levels of apolipoprotein A, associated with good cholesterol, but interestingly, they also exhibited a 40% reduced risk of irritable bowel syndrome. The authors of the study, including Professors Nofar Geifman and Anthony Wetton, have called for further research to explore the connections between ultra-processed plant-based foods, inflammation, and mental health. Despite the potential health concerns, the researchers acknowledged that PBMAS can assist individuals transitioning to vegetarian diets and support sustainable agricultural practices. The study, based on data from the UK Biobank with over 500,000 individuals, does have limitations, such as a predominantly white UK population and dietary data collected only at the study's outset. This restricts understanding of dietary changes over time. Previous studies have also linked ultra-processed vegetarian options to a 15% increased risk of heart attacks and strokes, while consumers of plant-based ultra-processed foods face a 7% higher risk of cardiovascular conditions. Conversely, increased consumption of unprocessed vegetarian foods is associated with a lower risk of heart disease, underscoring the importance of dietary choices. As veganuary approaches, the demand for meat alternatives is expected to rise, prompting supermarkets to prepare promotions on meat-free products. Researchers are exploring the use of ketamine as a potential treatment for severe depression, with a new focus on its effects on brain cells and circuits. Recent findings have challenged conventional understandings of how ketamine works, revealing that its antidepressant effects primarily target astroglia, which are supportive cells in the brain, rather than neurons. Imaging studies have shown that ketamine increases calcium levels in astrocytes, leading to prolonged activation of these cells even after the drug is no longer present. In experiments conducted with zebrafish, scientists noted that ketamine suppressed behaviors associated with feelings of futility, which are linked to giving up signals. A brief exposure to ketamine resulted in a significant and lasting reduction in passivity among the zebrafish, suggesting that the drug may enhance resilience against such feelings. The study also examined other fast-acting antidepressants, which similarly reduced passivity, while stress treatments were found to increase it. Similar mechanisms were confirmed in mice, indicating that astroglia play a significant role in depression treatment and suggesting that these effects may be conserved across species. Ketamine exposure led to an overstimulation of astroglia, allowing zebrafish to persist in swimming even when their efforts appeared ineffective. These findings highlight the importance of understanding the molecular actions of antidepressants, as their mechanisms have remained largely unclear despite extensive research over the years. Researchers stress the need for further investigation into how ketamine affects norepinephrine levels and its impact on both neuronal and astroglial physiology. This research opens the door to developing safer and more effective antidepressants by focusing on the activity of astroglial cells. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.